good morning, good night, depending on the, I see people from all over the world. My name is Marco Russo. I'm here today to talk about DAX Studio. So the idea is to spend 1 hour mainly doing demo. I just have one slide to introduce the product, and then I will show you the main features. The idea is that we start from scratch, from the beginning. My goal is to show you what you can do and why you should use DAX Studio. Showing you also a few of the latest features, because I have a new version that is not released yet, but this way also people who already know DAX Studio will see something new. A small feature, not something important, but. So, my name is Marco Russo. I'm from SQL BI. Let me see if I can change the slide here. Come on. I've been already introduced. So on SQLBI.com, you can find a lot of tools that also can work with DAX Studio. I will talk shortly about that later. And this is the only slide I have for DAX Studio. So basically, DAX Studio is a must-have tool for anyone who creates DAX measures, DAX calculate columns, calculate tables, or DAX queries. So DAX Studio is an open source tool written in C#. 90% of the code has been written by Darren Gospel, who lives in Melbourne, Australia. And there are a few other contributors, including me, but I wrote a small part of that. So actually, most of the merit for this huge product is by Darren, who is a Microsoft MVP. You can download daxstudio.org. You can download the file from this website, daxstudio.org. Here, you can also navigate to the documentation online, where you have screenshots and descriptions. The documentation is never up to date to the product, so you will see that there are a few old icons and features. But if you have bugs to report or suggestions to make, there is a GitHub repository where you have all the issues, open issues, discussion, and so on. And you can also contribute to the program. If you are able to write C# code, this is an open source tool. You can join the repository, you can fork, you can do many things. Now, for those of you that are not technical or developers, what happens once you download DAX Studio? You install a tool, and the tool that you install basically does this. I have, for example, Power BI. Here I have a report in Power BI, and you see that the latest version of DAX Studio installs itself as an external tool to Power BI. Now, you can always run DAX Studio as a standalone application, and you can connect it to analysis services, Visual Studio, Power Pivot in Excel, and Power BI. But the easiest way to run DAX Studio now is I open a Power BI desktop file and I click DAX Studio here in external tools, because DAX Studio writes an information about where he is installed, where it is installed in the directory, and it offers an icon in Power BI. So when you open DAX Studio, now in this case, we already connected DAX Studio to Power BI. What does it mean? You see here, let me just change this a little bit. So I will show you that in the metadata pane that we have here on the left, we have the same list of tables that we have here. And if I open, for example, sales here, and I scroll down, then I go back to DAX Studio and I go to sales, I see the same information. So the idea is that we have a tool that is called DAX Studio that is connected in real time to the same data, to the same internal database that Power BI has. There will be, a lot of details here about how this works, but basically Power BI has the same engine that you have in Power Pivot and in analysis services. And DAX Studio is able to connect to this engine that we call the tabular engine. The tabular engine has a set of tables, relationships, and so on. And what you can do here in this area, you see that the latest version of the next version of DAX Studio has this introductive text that says, okay, you have to just write a query here. Because the idea is that DAX Studio is like SQL Server Management Studio for SQL Server. You can just type queries and see the result. Much more than that. But so how can we write a query? You can go here, or you can start writing the query in DAX. Now, a query in DAX starts with evaluate, and then you have to write a table expression. And the easiest table expression is just a table that has one row, one column, with these curly braces, and I can write, for example, 1, 2, 3. Is just or better, hello, right? So we write the, oops, I made a mistake with the keyboard. We write the hello world program, right? So this is my hello world in DAX. When I click run, I run the query, and you see here in the results pane, the result. You see that DAX Studio has this feature where I can always move my mouse in any pane, and I can move the mouse wheel to zoom in and out. You know, we do a lot of demos, so we made this feature for us. Now, reality is that usually we want to write a query, but why should we write a query in DAX Studio? This is the first problem. If I have to write a query to execute a simple expression, this is not needed when I use Power BI. So let's go back 1 second in Power BI and think about what we see here. We have a report here with a bar chart. You see this is a bar chart. Now, when you run a report in Power BI, actually what happens is that for every visual, Power BI generates a query. There are one or more queries for each visual in the page. So if I refresh all the visuals of this page, you see that every visual has a different, you see that when I move this selection, I select a different visual. And when I select this, the first one, the margin, this one, margin and sales amount by continent, you see here there are information about the performance. But what is important, I have this copy query, which is the request that Power BI made to the tabular engine in order to retrieve the data to populate the chart that you see. And this query is actually something that we can just paste here. Let me reduce the font a little bit. We can paste the query here, and we can just execute the query. So what am I doing now? Even though I don't know DAX, or I don't know the DAX syntax for a query, I can just copy and paste the DAX code from Power BI, and I can execute the code and see the result here. You see that the result that we see here is the result that has been rendered in the bar chart in the visual, according to the visual, but the visual code receives actually exactly this content. And when you have, so why should we use DAX Studio? Because we want to check whether the numbers are correct. We are modifying the query. So we will see one use case. I want to investigate what happens when I change something in my measure. Use case number 2, I want to see the performance. I want to analyze the performance of my query. If my query is low, I want to analyze what is going on. And DAX Studio allows me to see the query plan and something else. Or I may want to simply analyze the model, or I may want to extract data from the model. So we already have 4 use cases. Now, let's say that all these things are interesting, but another thing that you can do is this query builder that I will show you in later. But the idea is that we also have a way to create a query from scratch, even though we don't know DAX. So let's start from the beginning. Now I just provided you a very, very, very high-level overview, but now let's start doing, analyzing the several features we have. First of all, DAX Studio is a DAX editor. So you can write code here. So for example, if I write evaluate, summarize, and I write, for example, sales, customer, country, you see that when I write, I have a minimal help. We can call this similar to IntelliSense, but IntelliSense is a trademark from Microsoft, so we have to call it autocomplete. This is not IntelliSense, guys. But this is an autocomplete that today is not as advanced as the one that we have in Power BI. So don't expect the same level of help. But this is a minimal help, and you see that here we can also click on Format Query to call DAX Formatter. DAX Formatter is a service that is called when we want to format the code, and you can choose here whether you want the short line or the long line. So you have two different styles for formatting the code. You can also have you can also comment a line and comment a line. This is a classical, simple features we have in an editor. Now, these features, swap delimiters, is something that for people who live in Europe probably is more interesting because it allows you to swap from the comma to the semicolon or the opposite in a DAX expression. Now, I suggest you, when you use Power BI, you should use the Power BI with the international settings, so that even though you are in Germany or in Italy like I am, I always use the comma as a list separator. But in case you have Visual Studio or Excel, or you have Power BI configured in a way that still uses the local settings, which is not the default anymore, then you can use this to switch between the two ways. And this could be important for one use case that I will show you in a minute. So, classical feature for the editor, but let me spend a word about the output. Now, the output is a grid, but actually we have different choices here. We could save the output in a clipboard. So if I run the query now, oops, I have to fix this. So if I run this query now, you see that batch is completed. I don't see the result, but the result is in the clipboard. So if I go here and I paste my code, here we go. I have the result in a clipboard. And the result could be exported to Excel. Now, if we export this to Excel, this is interesting because what happens if I do this? First of all, let me get a more interesting query. So let's start, for example, from the top 10 customer here. And I copy the top 10 customer, which is a more interesting query I want to execute here. I paste the code here, I format the code, and I have my query that returns the top 10 customer. If I run this query here in the grid, it shows me the data here. Now, let's say that I want to show this data in Excel. Now, first option, I save this into a static Excel file. So it asks me where, so demo1. And what I get now, oops, I have to open the file. Give me 1 second. I have to go here. I open in another window this file. And the file I saved now is a simple Excel file that has this as a table. You see that the content here is actually formatted as a table, but is actually data in the Excel file. Now let's use the second option, which is linked. This is more interesting because if I run this, what happens now? The file that is saved now is an ODC file. I have this window. Oh, I cannot move the window, but now Windows is asking me in a window that I cannot move in this screen, which program I want to use to open this ODC file. And here we go. Now I have here the ability. So usually the ODC file is automatically opened by Excel. I don't know why it is asking me to do this now. That's interesting. Because probably Excel here is not installed the right way. I'm using a different computer. So let me see if I can find Excel.exe here. That's bad. That's bad. So maybe I have to show you this later because let me try again. So if I use this and I use this, where did it save this file? So I'm trying to understand because this is usually automatic and it is not working. So what happens in this case, I will check this later because I don't want to spend too much time on this. But what happens is that you save an ODC file, the ODC file is open in Excel, and in Excel you have a table with a query that you can refresh. So basically it stores in the Excel file a connection string plus the DAX query that can be executed over the database. Now, if you're connected to Power BI Desktop, it's not very useful, but if you connect DAX Studio to Power BI service, if you have a Power BI Premium, you can do that with the XMLA endpoint, or you can use Analysis Services or Azure Analysis Services, You could create an Excel file that retrieves data from a DAX query in a simple table. And this is very efficient if you have a long list of names that you want to extract from a Power BI database, for example. Sorry for that, I have to check this data. And of course, I can save to a text file, or I can use this as for the timer, but we will see this later. Now, what can I do? What can I do with this query more than this? So here you see that when let's say that here this query is showing me the sales amount. The sales amount is a measure that I have in my report. And one common use case for DAX Studio is to try what happens if I apply a change to a particular measure. What does it mean? Think about this. When you have a complex model, maybe not this one, this is a simple model, but imagine you have a complex model with many measures and many reports. Now, this measure is very simple, but sometimes the measure is very long. And you want to see what happens. Imagine you have a number that is not correct. You want to see what happens if you change something into the measure. Now, when you make a change here in Power BI, sometimes the time required to modify a measure and then to enter the new measure, and you have to wait for the measure to be executed, sometimes it takes seconds. Because when you have many tables, many columns, and many measures in the same model, every time you confirm a new measure or edit an existing measure in Power BI, it takes a while to refresh everything, just to validate the syntax, basically. This is not required in DAX Studio. So DAX Studio allows me to be much faster in doing this and to be more accurate in the analysis. For example, if now I change this from net price to unit price, I'll show you this example, and I click enter, you see that I have to wait, and I have to, and I see different numbers here. So let's pretend that this is the wrong measure, unit price. You have seen that now I'm waiting 1 second probably, but sometimes this waiting time could be 10 seconds, 5 seconds or more, depending on the complexity of the model. So if I capture the query, I can do this. I can search for the measure I want here, for example, sales amount, and I can right click and define the measure here in the DAX Studio editor window. I can click format, I can see the code formatted. Now, this is the same definition I had in Power BI. If I run the query now, what happens is that my local definition of the measure overwrites the existing measure definition in Power BI. And you see that the numbers here now are the same, the same wrong numbers I have in Power BI. If I make a change here, and I, for example, write net price, and I click run again, you see the numbers changed here. I didn't change the measure in Power BI. Power BI is still intact. I didn't make any change. I'm simulating what would happen if I change this measure in my model. Okay, this is the idea. So I can try the effect of a measure in DAX Studio without actually changing the measure in Power BI. And this is very good when you have to make some tests for performance reason because the number is not correct, without risking to break the existing code. You can just test this here without any problem. Now pay attention, because when you have more measures, so if I click here, you see that in this model, I have, for example, margin, right? The margin is defined as sales amount minus total cost. Now, when you have the margin, and the margin is defined in the model, changing sales amount in DAX Studio doesn't affect other measures that are defined in Power BI. So if I want to see the side effect of changing sales amount also on other measures that are using sales amount, I have to include all these measures in the DAX code here. For this reason, we have a feature here which is define dependent measure. What does it mean? I want to analyze margin, but margin might have references to other measures. I want to see the entire chain of measures here. And so you see that because margin uses sales amount and total cost, I see also sales amount and total cost. sometimes you bring in 20, 30 measures just by doing this command. And it is much faster than finding the required measure by one. Now, if I change something here, the side effect of the change I make to total cost also propagates to margin because everything is defined here. And another feature we have, and this is sometimes useful, remember, margin is defined as the difference between two other measures, right? So one way to see this is that, okay, I can see all the measures in the dependency chain that I have. Or I could say, define and expand measure, which means that I want to see a single measure definition. Let me format the code here. You see that here I exploded all the measure references. So now I have a single DAX expression without any measure reference in the middle. And sometimes this is useful to understand the complexity of a measure you're evaluating. Sometimes you say, oh, this measure is low, but just because this measure internally calls hundreds of other measures. And you can realize that by looking at this kind of code. So these are features that you have in DAX Studio that could make it easier to author your measure. So even though I don't know how to write an evaluate statement, I could just copy a query from Power BI, inject the DAX code I want to replace in my query and see the result. I just need to edit the DAX code here. I don't need to understand how the remaining part of the DAX syntax work if I want to do that. And to be honest, I do this all the time, so it's a very common practice. So what else? Let's say you want to use, I think, let me see if I can open Excel here. So Excel here. Okay, here we go. So let's say that I want to connect this Excel to Power BI. So you see here that here I can connect to a database, and I could connect to analysis services, and if I know exactly the syntax to write, I could connect. So let me try to describe what I'm doing here. So DAX Studio has in this corner, you see this name, localhost 56816. I can copy to the clipboard this name, and I can paste this code here. Okay? If I do this, I can create a pivot table connected to my Power BI model. And you might say, Marco, what does it mean? I mean, this is analyzing Excel. Yes, I know, but think about this. If I double click this, I obtain a table that is executing a query over my analysis services or Power BI database. And you can edit this query. So if I go here, table, edit query, you see here, this query here is a query in MDX, but actually this connection string is the connection string to my Power BI model. You can put here any query. For example, if I copy, let's go here in external tools, view, performance analyzer, and start recording, refresh visual, top 10 customer. Remember my top 10 customer. If I paste my code for the top 10 customer here, this is similar to the demo I wanted to show you before. Once I have this, every time I refresh, if I go here and I refresh this, the query is executed again. Now, you see that in this model, I have one pivot table, which could be very slow if you start including a lot of columns with the customer name, address, and so on. But when you need just a table with the data, this is orders of magnitude faster. So another use case is that, okay, you could use Excel to execute a query and populate the data here. But at this point, you have a problem. How do you write a query? The second use case for this is instead of using Excel, you might want to use paginated reports. Paginated reports can query a Power BI dataset, which is exactly the same Power BI file you have, but you need to write a DAX query. You can use the query builder that is embedded in paginated reports, but is not so advanced. And I think that by default, it generates MDX code that is not as efficient as DAX code when you query a tabular model. So we have in DAX Studio this feature, Query Builder, that is enabled by default in the next release of DAX Studio. If you have the version 2.13, you have to go in Options, Advanced, and here in the Preview feature, you will see a checkbox to enable this feature, Query Builder. Okay, now it is enabled by default in the 2.14. So when you have this, you can do the following. You can say, okay, I want to group by city and by country and city. I want to see the sales amount. So I go here. You see that I'm just using drag and drop. I want to see the margin and I want to see the sales amount. And I can run the query and I can see the result. You see the result of the query, but you can also edit the query. And so you can see the DAX code required to generate this code. And of course, you can also apply filters. So for example, if I want to see just one product color, I can go here and I can say, okay, this should be red. And if I edit the query, you see that now the new query has this filter with red and so on. So it's a simple query builder that actually generates efficient code to retrieve the data that you want. You can also create a new measure for this query, which means that here I want to create a measure that says, for example, show me the margin. Let's see if I can do this here. Margin multiplied by 2. Okay. So I created a local measure. Let me remove this here. And if I edit the query now, you see that my measure has been defined as a local measure in my DAX query. So again, it's still in the initial stages, in the initial version, but it's already a better query builder than everything we have seen so far from Microsoft, because Microsoft never produced a good query builder for DAX code. Okay, so I think that we have seen everything at this stage. So for the query builder, I mean, I could continue, but let's move to some other feature. Now, because I'm extracting data from the model, this is something that we didn't expect. When I worked with Darren to DAX Studio for many years, and we never, ever thought about the idea of using DAX Studio to export data from a data model. Because we said, okay, if you have the model, you also have the data. But the reality is different. Many users can access the result of the dataset or can access the Vpx file, but they don't have access to the original data source. And they want to extract the data for some other reason. So we have seen people who were writing here, evaluate, for example, customer. In DAX, let me close this. In DAX, this is show me all the columns, all the rows from the customer table. Select star from customer table in SQL. And then they were copying this data to Excel. Actually, we didn't have Excel once upon a time. We just had the file, so they were saving a CSV file, and they were importing the CSV file, blah, blah, blah. And maybe they wanted to populate a SQL Server database with these tables for some reason. So for this reason, we have now the export data feature. Now, if you want to export just one table, probably you want to use this technique that we have seen now, or query builder. But imagine you want to export all the tables from this model. And you want to export this table where? To a CSV file or to SQL Server tables. Let's say we want to export CSV files. So we want to save the tables here in demo. We want to use a CSV file. And we want to store not all the tables, let's say customer date, product, category, subcategory. I'm trying to not export the millions of rows. And that's it. And I click export. Now you see that the performance of this export is extremely fast. And now I have in my demo file here, I have all these files, these CSV files that have been created on the fly. Now the performance is very good also when you publish this data to SQL Server tables, and the SQL Server tables are generated on the fly. You always you clearly need the write permission on the SQL Server table where you want to write this data. So I never use this feature, but I know that many people really rely on this feature because they can do further analysis with Excel or with other tools without having to, because they don't have access to other data sources. So we have seen DAX Studio as a query builder, as an environment where we can execute the query, as an environment where we can look at the DAX code that we have around. But as I said, we have also the other features, like, for example, this one. What do I have in my model? How many rows I have in each table? If you look at what happens when I go over a table, you actually see that there is an information in the tooltip that says there are 26 columns and 18,000 rows here. When you click on the table here, you see that for each column, you can see some other statistics like the minimum, the maximum value, and a sample of the data of the column. But what if I want to get an overview of my model? You can click on View Metrics. When I click on View Metrics, DAX Studio extracts statistical information from the model, populating this Vertipack Analyzer metrics pane that shows the data for my model. Let's start from the summary. I have 300 megabytes for my model. My model requires 300 megabytes of RAM. And I see that the RAM of my model is split across these tables. The table size says there are 312 megabytes for the sales table, 4 megabytes for the customer table, and so on. When you drill down a table, you see column by column the cost of each column. And you see that here there are two columns, online sales key and order number, that alone they are 50% of the entire database. So I can quickly realize where I'm spending the memory of my model. Now I'm using here another product. It's always a free open source tool, which is called Vertipack Analyzer. Vertipack Analyzer is another library, an open source library that is integrated into DAX Studio. That the library retrieves the statistical information and provides the statistical information in several ways here. We have information about the columns here. We have information about the relationships. We have, this is a new feature of this version, this 1M ratio percentage that we have to explain in an article. But we have here the list of all the relationships with a number of information about the cardinality and the cost and the direction and the type of the relationship. We have information about the partitions. We have many information here that could be useful to understand where you're spending the memory of your model, or when you optimize the DAX code, it's very important to know how many rows you have in the table, how many unique values you have in each column, for example, and the cardinality of the column is exactly this information. Now, when I optimize my DAX code, which is the next feature I will show you, I always use Vertipack Analyzer. But Vertipack Analyzer is important for another reason. I can save this information in a file. If I click on Export Matrix, I can save here demo Marco. A Vpx file. The Vpx file contains, in a very small file, all the information you have seen here. And so let me show you. This is the Vpx file, is just 40 kilobytes. There are no data here. There is no content of the tables. The only thing that we have is the definition of the table, the columns, and the statistics about the tables and the columns. How many rows, how many unique values, but not the content of the table. If you rename this to a zip file, you can examine the content. These are JSON files. Everything is visible as text file. And I'm saying you this because when I have to do an analysis for a model that is stored on a remote server and I don't have access to that remote server, imagine the situation. Many of you probably are consultants. There is a problem in production for a model you built, but you don't have access to the production server. For some reason, they don't provide you the access, and you're not able to understand what is going on. So if you tell to the administrator that has access to the production server, get the Vpx file with DAX Studio and send me in an email this Vpx file, what you can do is the following. I can open a new instance of DAX Studio here. Imagine I have my DAX Studio here. I'm opening a new window here. This DAX Studio is not connected to anything. I don't have any connection active, but I can import the file I saved before, and I can see here the same information. The same Vpx file can be imported by Vertipack Analyzer, the tool, which is an Excel file that can import this file, providing you additional insights about the information here, because here we don't have information. This pane doesn't have the details about the compression rate or other many details we have in the larger version of Vertipack Analyzer. But the starting point is this small Vpx file that is easy to transfer and doesn't contain any data. Is a very easy way to get an idea of what is going on a remote server without having access to the remote server. And so we have seen that this view matrix is the integration we have of Vertipack Analyzer in DAX Studio. Now, as I said, this information is very important when I want to analyze the performance. And now we go to this last section, which is the traces pane and the Power BI load performance data pane. So let's start from this one. This one is specific to Power BI. Let me explain. You see that when you work in Power BI with the performance analyzer pane active, all the actions that you do in a report are logged together with the information about what happened in every visual. Now, this information can be exported. You can export this information in a file. So here, demo, Power BI performance data.json, but you can call it as you want. It's a JSON file. It's a text file. It's called twice. I don't know why two. Okay, let's call this two. Okay. Now I have this file, and what I can do once I save this file, I can open this file in Power BI. Why should I do that? Well, the reason is the following. If you know how the performance analyzer works in Power BI, it always shows you the data grouped by the event that generated that list of visual operation. Let me show you. You see that I always have event, action, 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 event, action, action, action. Okay, so this is the idea. You can change the sorting here. So for example, you can sort by, I don't know, total time, DAX query time, okay? But actually the sort order is always within the single action. So the sort order is always local to every event that triggered the action. So when I export this data here, I no longer have this, this division, which could be useful when you want to retrieve all the slow queries for the query time or for the rendering time, which is the time spent in the visual. So it's another view over the same information you have in Performance Analyzer. There is some additional detail here that you don't have there, but actually not much. When you see that there is something that you would like to test, you just double click here and you have the DAX query that you can copy and paste. But as you see, there is a comment at the beginning with additional details that you don't have when you use copy and paste, for example. So this is a feature that allows you to actually read the information about the performance analyzer you can export from Power BI. Now, this feature is only for Power BI, not for Power Pivot, not for analysis services. These other features are useful for all the engines, including analysis services, including Excel. And let me show you all queries. All queries works this way. At this point, you see here, there is a new pane that now is empty. And when I do something, so for example, if I click here on a slicer, now as long as I click on a slicer, I already clicked before, Power BI is not generating any new query because it's answering to the new request using the previous result of the query. So there is a cache in Power BI that doesn't even call the engine. But if I go to a value, for example, I think if I have a combination of 2 or 3, these are new queries. And you see here, every time I have new queries, they come here, and I see the user who made a request, I see the query, and I see the duration. This could be useful when you connect to a server, analysis services, for example, where there are many users connected and you want to see who is using the model, what are the queries that run, and so on. And again, if you double click here, you have this. I have to say that now that we have the performance analyzer in Power BI, we no longer use these all queries so much. I still see people using this feature when they connect to Azure Analysis Services or to SQL Server Analysis Services on-prem. But the other use case for DAX Studio is analyzing performance. So let's go back here and let's assume that this query is slow. So let me make this slow. So let's say that I do this. Okay, let me create a total sales. Okay, I create a new measure. I do a stupid thing here. So say bad sales, which is equal to sum x of the sales, sales amount. This is enough to create a problem in performance. Okay, so I put this measure here, bad sales, I put this measure here. You see it takes a few seconds now. It took a few seconds to populate this. And I can capture this query, copy query, and I can paste my code here. This is my query. At the moment, we don't look too much at the query. I want just to show you what happens. If I run the query again, you see that I have the result, and I have in the output, this query has been executed in 700 milliseconds. Now, in reality, this is executed in a faster time because there is another cache in the engine that probably saved me from waiting 1 or 2 seconds. Let me try to clear the cache. You see this button, clear the cache and run. This cleared the cache that is in the engine, in the DAX engine. And now in the output, you see here that instead of 700 milliseconds, which was the previous execution, we spent almost 2 seconds. A better way to see this information is in the query history. The query history keeps track of the time spent in each query you executed. And you see here from 600 to almost 2 seconds. The time is always in milliseconds. Now, if I have a query, from my point of view, a query that runs in 2 seconds is slow and I want to optimize it. So how can I do this? You see here we have query plan and server timings. So when you click this, a new pane appears here, query plan, but pay attention, you have to wait 1-2 seconds because there is an activation of the tracing that could require time, and you have to wait 1-2 seconds. The best thing to do is waiting to see this sentence here in the output. You also click on server timings because we have 2 panes. One shows the logical and physical query plan, and the other shows information about the storage engine. Let's see what happens when I click run. You see that the query is executed, and I can still see the result here. But in the query plan, you see we have, so let me enlarge the screen now and enlarge the font. We have this. This is the physical query plan. This is the logical query plan. I know if you expect something graphical, forget it. This is the information that Microsoft provides. Yes, there is some useful information here, but usually the list of the data we see in the logical and the physical query plan is very verbose. We see a lot of lines, and sometimes it's very hard to understand what is going on at this level. So in DAX, we don't start analyzing the query plan. We start analyzing the server timing pane. This pane is easier to understand because here we have the time spent in the query. Now we spent 743 milliseconds. As you see, this time has been spent between the formula engine and the storage engine, which are the two elements of the DAX engine. But one of the internal storage engine queries was retrieved by the cache. So in the worst case scenario, you have to assume that the cache is empty. So what we do is always clear the cache and then run. Because we do this often, we can change the behavior of the run button so that every time we click this button or we click F5, which is the shortcut by default. By the way, you can configure the shortcut if you want. When I click run, there are two things happening. First, the cache is cleared. Second, the query is executed. So this way, I always execute the query in the worst possible condition. And you see here that there is something bad happening because this storage engine query required almost 2 seconds of CPU, and because I had several CPUs here, actually I waited for 1 second and 100 milliseconds. And then the formula engine had to spend a lot of time doing the calculation. Now, at this point, of course, we have to start 3 days optimizing DAX lesson, which will be too long. I just want to show you that what I do at this time is the following. First of all, here I have 3 measures. Which one is the lowest one? We can try. Let me comment this one. So I comment this one, I remove the comma and I run. What happens? Now the query runs in just 23 milliseconds. So I'm pretty sure that this is the slow measure. I want to isolate one measure that is low because I want to optimize that measure only, and I optimize one measure at a time. So if I run this query again, I see that yes, the query is low because of this measure. Basically, what I'm doing, I reduced the output of the query to only one measure that I see here. Now, because bad sales is the measure that I want to optimize, what I do now is that I go here, I search for bad sales, I right-click and define the measure here, and now I can see what happens here. Now, the problem of this measure is that I wrote a stupid measure. The sum x sales amount that doesn't make any sense. I have to either just call sales amount here, or if I wanted to use an iterator over sales, I cannot use another measure because this generates 2 nested iterators that you can easily see if you do this other operation. Define and expand measure. Look at this. By writing a measure within a measure reference within an iterator, what I'm really doing is for each row in sales, wait a minute, how many rows do we have in sales? We have 12 million rows. So we're saying for 12 million times, calculate, which is a subquery, a sum x over sales, 12 million rows. Now you can imagine that iterating 12 million rows, a table of 12 million rows, will take some time, and 1 second is actually very fast. My problem is that because of the context transition, the innermost calculate will iterate only 1 row at a time, or maybe more than 1 if there are duplicate values in sales. But this is clearly a mistake I probably wanted to just retrieve. I wanted to reuse this. I wanted to do this. I wanted to multiply unit price by quantity for each row in sales. And if I run the code this way, this code runs in just, let's go here, 55 milliseconds. Now, you see that every time I run the code, the time could be different. 54, 55, 20, 23. So when you see, first of all, any number below 20 milliseconds, it's just noise, ignore it. But when you see different numbers in every execution, especially when you connect it to a server, to a remote server, where you also have the latency of the network, it's a good idea to run a benchmark, which means I want to run this query 4, 5 times, 3 times, And you can also choose whether you want to clear the cache every time. Call cache execution means I want to clear the cache every time. Warn cache execution means I don't clear the cache in every execution. And depending on the query, you might want to use only one or the other. For example, here, I want to run this 5 times in call cache. So I clear the cache every time. And actually clearing the cache sometimes is slower than doing everything else. When this completes, it provides you information about the duration, the average, the minimum, the maximum, and so on. It is not the case for this particular example, but there are several cases where you want to do this because you have a different timing in every execution. So this is the feature. So if you want to know more about this, we have articles, sessions on YouTube, videos. There are many things where you can find additional information, not mentioning the courses and so on. But even just if you want to start, there are interactive videos for each of these features. I just wanted to provide you a general overview. Just before closing and looking at questions, these 2 external tools you see here are basically a way to open Excel using the ODC file that is not working in this machine. I had to configure something, sorry for that. Or SQL Server Profiler, open the SQL Server Profiler, which is a tool that is included in SQL Server Management Studio and actually creates a trace session using the same technique that we use in DAX Studio, but actually this is the tool provided by Microsoft that can analyze what is going on in all the trace events. This could be useful if you want to analyze, for example, the processing time for Power BI. Imagine that you have a slow refresh because of some calculated column that is very slow. What you may want to do, you want to, for example, go here in progress reports. Here you want to capture the progress end event so that every time there is an action in the refresh, which could be also just the refresh of a column, you will see an information here with the timing of each column, how much time has been spent for each column of your model, for example. And this could be useful to evaluate which calculated column is very slow in your refresh. And this could be one of the reasons why you might want to use the SQL Server Profiler. SQL Server Profiler can be installed if you install SQL Server Management Studio. When you install SQL Server Management Studio, which is free from Microsoft, you get a SQL Server Profiler. So just get the latest version of SQL Server Management Studio and you have SQL Server Profiler too. Okay, I don't know if I forgot something, but let's see if we have questions.
So thanks very much, Marco. That was brilliant. I think you got through nearly all of the features that are available in DAX Studio in an hour, which is no mean feat. So we had a couple of questions. So one of the first questions was around the query builder feature. So if you build a query with Query Builder, does that understand the model relationships as well and respect the relationships?
Okay, so I'd like to answer to this question showing Query Builder again. As you see, this query is using customer, product, and sales amount, which is a measure using sales. The relationships in DAX are always in the model. It's not required, and actually you cannot write the relationship in the DAX code. The DAX code does not have relationships at all. Relationships are part of the model, and this is the big difference between a relational database like SQL Server and a semantic model. The semantic model is tables plus relationships plus measures. When you invoke a measure or when you write a DAX statement, relationships are always part of the model, just like you don't have to specify that a column has a data type in a SQL query, right? Because it's part of the model. But in SQL, you don't have relationships. You have foreign key constraints that don't tell to the engine how to join tables. In DAX, you have a semantic model where the relationship is a fundamental part of the model and is always included in the join. If some entity of that table is included, you can disable a relationship, you can enable an inactive relationship, and this is the only thing you can do in DAX, but you cannot generate relationships on the fly. Also because every relationship has indexes that help the performance of the query. There are functions to join tables in DAX, but they are way slower, way slower than the natural join you have for the relationships in the model. So you use them only when you have to join temporary tables that you create on the fly in your code, not when you have tables in the model.
Okay, brilliant. And then another question on if you're searching for a measure or a column, does that actually look in the DAX code, or are they just looking at a measure or column name? So someone wanted to check to see if things had been either hard coded or something else within the DAX, or are you just searching for measure or column names when you're searching in the model?
When you search, it depends. So if you make a search here in the metadata pane, you search for any entity. For example, if I write sales, I see tables, columns, measures, but the icon shows me the data type.
Okay.
Right, the type of the entity. If I go in this editor and I press Control Find and I search sales, this is just a text search. So I just look for something that has sales in the name, but is just a text editor. It doesn't have a semantic meaning of what I'm searching.
Got you. Okay. A lot of people really like the idea of the data export feature, and then questions about are there possibilities to automate that data export feature?
Sorry, the possibility of
automating the data export?
That's a good question. I don't remember because this is not the first time I hear this. Okay. I don't remember if you can run DAX Studio with a command line. I don't remember. I remember that we talked about this. I don't remember if they implemented it. Let me see. Export.
I think somebody else may have checked the GitHub repo as well.
I don't remember. I have to maybe in the document. But the documentation.
Yeah.
I don't remember. You have to check the. Let me see the change log. Export. It is. No, I remember. Okay. Try to write on. If someone is interested in this feature, look for in the issues request or just write a new request, because I remember we discussed about it, but I don't remember if it was something we didn't implement or it is already implemented. I don't remember the command line. The idea was to have a command line to automate this, but I don't remember if it is already implemented or not.
Right. Okay, that would make sense. And then I think what the last question was from Jochen. So is there an option to clear the session cache which doesn't need SSAS or Azure AS admin permissions if you're connecting to analysis services?
The cache is local to the database, and when you clear the cache, you clear the cache for the database. An interesting thing is that I recently tried, and this works also when you use Power BI through XMLA endpoint. Which implies that you have to be an administrator of the database. If you have only write access to the database, you cannot use the trace, you cannot use the performance features, you cannot use the clear cache. Okay. Because read-write only, you can only run a query, you cannot do any other action over the database.
Okay, that's all of the questions I think for DAX Studio. So Hassan asked something else, but I don't think that's relevant for DAX Studio, I think. because the DAX Studio is for the model only, right?
DAX Studio is
for the model only, for the modeling and the DAX only. It's not. We can't do anything with visuals in DAX Studio because we're just looking at the model of DAX.
No. DAX Studio, yes, is. I mean, imagine is what is missing. Okay, DAX Studio is what is missing in Power BI, but actually we started DAX Studio before Power BI was released. DAX Studio started in 2012, I think, 2012, 2013, for analysis services. And because the technology is the same, we just implemented features. Darren just implemented features for Power BI.
Yeah, okay. So I think that was it. I think that there was one other question from one of the members, which Ian around. He's looking for some help on excuse me, modeling and so on, and working with denormalized databases. So I will pass you Ian's information along, Marco, and if there's anybody in your network or yourself, you might want to do that, to get in touch with them.
Okay. So I think I don't know.
I think we're done.
Looking if there is some other question. Okay. So that's all. If you don't have any further question, I think you can just play with DAX Studio. Oh, by the way, I forgot. Sorry, this is important. We have a free course about DAX Studio with maybe if you need. So if you go DAX Tools video course, it's free. So it's just here. You can register online, and I and Alberto recorded video course about DAX tools, which today includes DAX Studio, Vertipack Analyzer, and Analyzing Excel. And so especially for Vertipack Analyzer, where you have seen all those numbers, we didn't have time. It is another hour at least. So probably we have seen most of the features of DAX Studio, but again, if you want to review something, it's 2 hours. So especially for Vertipack Analyzer, it's a lot of content that you can use.
Cool. All right. So there was one question that I missed. Sorry. So from Alan.
No problem.
So is there a use case where you would use Vertipack Analyzer in DAX Studio versus exporting it out and using the Excel add-in?
Okay. It's simple. Usually I use Vertipack Analyzer in DAX Studio where I'm connected to the database I'm working on. When I receive a Vpx file from a customer, usually I use it in Excel just for a simple reason. The Excel version has a page with all the DAX measures, calculate all the DAX expressions of the model in a table where I can filter by table, by type, by measure, by calculate column. And it's like having a documentation of the model, right? But to me, when there is a user that has a problem with an with a DAX formula, I know that I have everything there, and I don't have to open anything. I don't need the special access to anything. I have everything there. Or in the unlikely case, I have to optimize a very large model where I want to see the details about compression and something else. But for Power BI Desktop, I never have this problem. So the only reason why I use the Excel version for Power BI Desktop is because I want to see all the measures without having the actual Power BI Desktop file. And that's the only reason. Actually, there is another reason. When you are in Excel, it's easy to do copy and paste and doing some filter or some other operation. You don't have all the filters and sorting options that we have in Excel in DAX Studio. But again, our side cases. Usually, when I just need to do a quick look at the data, I use just DAX Studio.
Okay. Thank you very much. I hope that answers. All right, cool. Thanks. Alan's happy with the answers. That's good. And again, thank you very much, Marco. That was a really brilliant session. I'm sure everybody enjoyed it. And a lot of thanks in the chat as well. So that's really good. Thank you.
Okay. Thank you very much.
Thank you very much. Thanks. Bye.
Thank you. Bye-bye. Thank you.
Bye.
Bye-bye. Bye.
Thank you. Bye-bye.
Thank you.
Thanks,
Bye.
guys.